We're going to review some statistics stuff today. The first one we're going to look at is a stem and leaf plot. So what exactly is a stem and leaf plot? The stem and leaf plot is a quick way to organize large amounts of data. When you are finding or creating a stem and leaf plot, the first step is to find the largest and smallest number and then identify the greatest place value. Step 2. Draw a vertical line and list the stems, which is the greatest place value, on the left. Our next step is to fill in the leaves on the right with the corresponding stem number and then arrange them in order. Finally, create a key. And the key is just a way for whoever's looking at the stem and leaf plot to be able to identify what the stem and leaf mean. Let's look at an example here. This one's on your sheet. We have a bunch of data in this table where each number has a tens place and a ones place. The one exception being 100 over here would have a hundredths place. So when you're creating a stem and leaf, what you want to do is, we just did step 1, identify the greatest and lowest. So 100's the greatest. It appears that our smallest number here is, I believe, 63. So now you're going to draw the vertical line. So here's our vertical line in this stem and leaf right here. And then we fill in the stems, which would be the tens place on the left and the ones digit on the right. So for example, our number 63 appears right here. The 6 is the tens part, the 3 is the ones part. So each number here corresponds, in this top row right here corresponds to a 60 number, 63, 65, 67, 68, which all appear in this table above. And then you just keep going on and list all the numbers out. If a number appears more than once, then you list the numbers 2 times. An example is the number 91 appears 3 times. And you can see that because you got 3 ones here. So 91 occurs 3 times up in this table, which means it has to be listed 3 times in the stem and leaf. So once you got them all in order like this table has, then the last thing is to create a key. And they have a key down here showing that a 7 on the left for the stem means 70. A 1 on the right for the leaf means 71. So that's an example of a stem and leaf. Let's try one out ourselves, see if we can make one for these weekly babysitting earnings. So like we just said, find the lowest and highest one in the table. And it kind of looks like our lowest one is at 21, would be the lowest amount earned. And if we look through all the other numbers, it appears our highest one is 65. So seeing that it's 21 and 65, we should list the stems here as 2 for 20s, 3 for 30s, 4 for 40s, 5 for 50s, 6 for 60s. Then you put the leaves on. So now we want to look, where are numbers in the 20s? Our numbers in the 20s, we got 21, 22, 24, another 21 it appears, and 23. So we're going to list those out, and we want to put them in numerical order. So there's 2 21s, so we need 2 ones here, a 22, so we're going to list a 2 for 22, a 3 for 23, and we also have a 4 for 24. And then you just kind of keep going all the way through listing all the numbers. When we're done, we should have 15 numbers on the right in our leave section because there's 15 numbers in this table. So we want to go through and do that. And we'll end up with a babysitting chart when we're all done that looks something like this. Now the last thing we need to do at the end, once you got all the numbers listed out, is we do want to create a table. So somewhere at the bottom, you want to create a table showing what a number means. Here's an example here. We wrote a 5, line 3, and then show that that equals 53, so that anyone looking at this table knows what the stem is and what place value the stem and leaf is. All right. Then when you have a stem and leaf, it's easy to answer some information. For example, the first question here, what's the highest fee earned? Well, now it's easy to see the highest fee earned. You can go 20, 30, 40, 65 is the highest amount earned. Okay. Why don't you kind of pause this, see if you can answer these other questions quick on your note sheet, and we'll look at them tomorrow and see what you get for these other questions. So see, using this table, if you can answer those other 3 questions. The other statistics thing we're going to look at is a box and whisker plot. A box and whisker plot is another way to quickly gather and interpret information from a set of data. In a box and whisker plot, we have some terms that you need to know what they mean. The first one is lower extreme, okay? The lower extreme. Lower extreme is basically your smallest number in your data set. So whatever the smallest number is, that's your lower extreme. Your upper extreme is the largest number in your data set. Median. And I'm going to put this Q2 here. Q2 is something we'll see when we actually write it out. But a median is your middle number. If there is a even, or if there's 2 numbers in the middle, there's 2 middle numbers, then you average those 2. Then you find the average. So it's the middle number, or if there's 2 middle numbers, then you average those 2. Lower quartile, and another word for lower quartile is Q1. Well, the lower quartile, when we graph these out later, is going to be, it's basically kind of the middle of the middle, and it ends up being the value on the left line of our box for our box and whisker. The upper quartile, or another word for that is Q3, is the value on the right line of the box. Interquartile range, when we start talking about range, that is in between 2 numbers. And the interquartile range is your Q3 or upper quartile number minus Q1, which is our lower quartile number. The range is the whole, you're using the whole graph now. So that's your upper extreme minus your lower extreme. So you take the top number in the data set and the bottom number and subtract them. Outliers. This doesn't always happen on a box and whisker, but once in a while you might get a number that doesn't really appear to be close to the other numbers. So outliers are values that are far away from the rest of the data. So they're numbers that are far away from the rest of the data set. The 2 other terms they may or may not use with when you're doing statistics is mean and mode. Mean is one you should be familiar with. That's just the average of all the data. And mode is the data point or points, sometimes it might be more than one, that appear the most. So whatever shows up the most is your mode. All All right, let's look at an example so you can kind of see this in action here. We're going to create a box and whisker plot for this information. It's usually easiest when you're doing a box and whisker plot if you can get the numbers in numerical order first. So let's do that. And when I'm doing it, I kind of cross them off just to make sure I got all the numbers. So it looks like 5 is our smallest number. Our next biggest number looks like 6. We got an 8, 9. It looks like we have another 9. Then we have a couple 12s. Actually, 3 12s. 13. 2 14s. 16 and 20. So if you can get them in order from least to greatest, that's step 1. Now, what you're going to do is you want to, we can answer a couple questions. What is the lower extreme and the upper extreme? It's easy to see now. The lowest number is 5. Our upper extreme, the biggest number here, is 20. All right, next thing you want to find, what's the median? Where's the middle? When you're doing this, you can look at how many total numbers you have. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So our middle is going to be the 7th number. And you can do that by average, taking 13 and divide by 2. Or if you want to just take your fingers on both sides and keep moving in until you get to the center, you can do it that way. But our middle will fall in this one right on the 7th number, which is right here. So that is our median. So our median here is 12. Now we're going to find our upper or lower and upper quartile range. Our lower quartile range is going to be the middle of what's left. So we got these 6 numbers over here. We want to find the middle of that. So the middle of 6 is going to be between the 3rd and 4th number right here. That's going to be our lower quartile. That's also called Q1. And our value for that, if it falls between 2 numbers, is to average. So we're going to average 8 and 9. So if you add 8 plus 9, it's 17. Divide by 2 because we're averaging 2 numbers. Our lower quartile is going to be 8.5. And that's because it falls between 2 numbers. All right, do the same thing with the upper quartile. Upper quartile is going to be between the 3 numbers over here, so it's going to fall in right there. And again, we got to average. If you average 14 and 14, our upper quartile is just going to be 14. That's also called Q3. So our upper quartile is 14. Our interquartile range then would be the difference. So if you take 14 minus 8.5, it'll give us our interquartile range. So 14 subtract 8.5 is going to be 5.5 would be our interquartile range. Our total range of our whole thing would be the upper extreme minus the lower extreme. So here 20 minus 5 means our range is 15. Let's graph this one out now before we answer anything else. So to graph a box and whisker, you make a number line. So we want to make sure that we can fit all our data on here. Okay, so we got our number line. And now you draw your box and your whisker. So our box, our median is 12. So there's the middle of our box. Our Q1 is at 14. And our Q1 or lower quartile is at 8.5, which is between 8 and 9. So there's the box. Now you draw the whisker out to your lower extreme and your upper extreme. On this one then, outliers, there is no outliers. There's no data points that don't appear to be, so this one has none. And then meat and mode we'll talk about in class, and we'll talk more about this box and whisker as well tomorrow.